Hello, and welcome to this episode of Better Buildings for Humans, where we talk about human comfort, health, wellness, productivity, and how the buildings that we live, work, and play in, affect all of those things. We've got a really interesting one today. I talk a lot about how much pressure there is on reducing glazed area in buildings, and so much of that is driven by the fact that we see a lot of heat loss through the framing in the glass systems, and the framing industry is stepping up. It's stepping up in a big way to make some changes so that it's no longer the weakest link or the weak link or anything like that. And that'll give us the opportunity to make some changes. So without further ado, let me introduce Steve St. Pierre and Kurt Miglas. Did I pronounce it right, Kurt?
Perfect.
Close
Yes.
enough. Kurt Miglas from Ensinger, and specifically from the Inselbar division. And I'm going to let them tell you about their background and their roles at Ensinger. So let's start with Steve.
Hey, Joe. Thanks for having us on the show. My name's Steve St. Pierre. I'm the design and application engineer at the Inselbar division of Ensinger. Glass and glazing industry has been fairly close to my heart, something I've worked in now for over 3 decades. Originally started as a skylight manufacturer, and there I started out as a estimator and moved on to engineering and design notes, and I was with them for almost 20 years. And one of the big tasks that we had with that company was to do AIA continuing education units. And the presentations were all based on the benefits of daylighting, how much it worked, how it generated the light inside the buildings, better teaching, better healing, all these different things. From there, I moved on to a multi-wall polycarbonate glazing manufacturer. I worked with manufacturers that were doing these very, very large expanses of translucent multi-wall glazed systems to bring in biggest focus was to being able to bring in more and better diffused daylighting into the building. Lastly, I landed here at Ensinger, where I now work with companies and designers to help better thermalize their windows, doors, curtain walls, storefronts, skylights, you name it. All of the systems to bring in more, better daylighting, and to be able to have much more efficient utilization of thermal values.
Just so important, so important. All right, let's hear from Kurt.
Thanks, Joe. Yeah, just to echo what Steve mentioned earlier, appreciate you having us on the show. Unfortunately, I'm still a little too young to have 3 decades of experience like Steve, but my whole career has still been centered around the fenestration industry. As you can probably tell from my accent, I am originally from Australia. So my family actually owns a window manufacturing business back there that specializes in high-end aluminum clad, or as we call it, aluminium, double glazed products. And I was there for over 15 years and involved in many elements of that business, right through from assembly, design, sales. And then one day I decided I wanted to sort of explore working overseas, and that's where my journey led me here to Ensinger, where I've now been for just over 2 years. My role with Inselbar at Ensinger is the sales and marketing manager for North America. And I work closely with Steve and the rest of our sales team to identify market needs, market trends, or obviously the topic today, for example, the increased importance of daylighting, and how our Inselbar product range aligns with our customers' needs to achieve this.
Oh, fantastic. So Steve will be able to share the insights with regard to technical and application, and of course, Kurt, insights into market trends. So this is great. I have to take advantage of having an Australian on the show and ask you, how similar is the market in Australia relative to North America?
Yeah, well, I mean, look, in the residential space, particularly, Australia effectively mimics the US style of windows. So, everything in Australia, or predominantly everything in Australia, is that open out style, crank style casements, awnings. And I think this is because the use of screening is very important in Australia. Australia is well known for having insects, which is why these open out systems, I think, are more popular. But like the US, we're also significantly behind in performance requirements and market expectations of what a high performance window is when we compare ourselves to Europe. Interestingly, thermal modeling in Australia is also directly derived from the US or the NFRC standards, and then just converted into a metric format. So design-wise, the transition for me was, to be honest, fairly seamless. I just had to learn my way around those imperial number conversions.
Yeah, I'm a Canadian, so I've got the I've got the same issues for sure. All right, now we need to learn what Ensinger does. Well, specifically what Inselbar does, and how your work is helping the effort of moving towards more sustainable building design.
Sure. Well, Ensinger overall is a global player in the high-performance plastic industry. Plastic in general can have a bad reputation, but I think it's really important to distinguish that this is different in high-performance plastics, which, when correctly used, processed, recycled, they actually have enormous benefits on the environment. And this is very, very different from single-use plastic, or the disposal plastic that many people just automatically visualize when you talk about the plastics industry. High-performance plastics are critical in many modern-day applications. Medical, aerospace, automotive, semiconductor, all those type of industries are heavily reliant on high-performance plastics. So realistically, the world that we know it as of now, it just would not be possible without these high-performance plastics. The Inselbar division, though, which Steve and I belong to, it's more of a niche application area. It's very specific to polyamide thermal brakes in the fenestration industry or building envelope industry. And we're a US-based production and application team, but we do have the advantages of leveraging our global plastics knowledge that our company has.
Yeah, very cool. Quick fact about me that most people don't know: I'm actually a chemical engineer, and I started my career in plastics. I made polyamide for DuPont back in the early 90s, and then moved to a company called Syro, where we were extruding multi-walled acrylic and multi-walled plastics, and that's what got me into the whole idea of letting light into structures. So I can certainly relate. Let's talk about thermal brakes. So thermal brakes, high-performing framing, and approved glazing. These are all, for very obvious reasons, becoming very popular in North America right now, and they very much under the microscope. Still nothing compared to Europe, right? How would you compare where we are relative to where to continental Europe and UK are now?
Absolutely, Europe is way ahead of us. But just a real quick history lesson on thermal brakes. You might find this a little bit surprising, but fenestration thermal brake technology actually began here in the U.S., not in Europe. And it started back in the 60s. Aluminum was always and has been material of choice for fenestration applications because of its strength, durability, design flexibilities, and however, one of the big major drawbacks of aluminum is it's highly conductive. This is why heat sinks and other thermal management products are made with aluminum cooling fins. You can also cook your food on it. If you remember, there's a lot of aluminum pans out there. As thermal performance standards began to improve and even be considered, it was understood that something was required to break the thermal conductivity between the interior and the exterior surfaces. So way back in 1962, long before Kurt was born, the Sol Steel Company, based out of California, developed the first chemical thermal barrier system, which they called Arctic Wall. This is now known in the industry as poured and debridged. In the 70s, this is where it started to change a little bit. It was discovered that polyurethane has a propensity to shrink, crack, and it's referred to dry shrinkage. Which then exposed a lot of the joints, especially in the corners of fenestration, to water infiltration and failure. So at this time in Europe, people were starting to complain about it. So they went to our founder, William Ensinger, who was a whiz with chemical engineering and plastics and engineered plastics, began working on an alternative thermal brake using polyamide with glass fiber reinforcement, which exhibited better structural performance. And the existing polyurethane technology in the materials that they had identical thermal expansion contraction rates of the aluminum, which is critical in long-term durability of the systems that expose to many thermal cycles. Polyamide products like the Inselbar range are effectively standard in Europe, while poured and debridged systems is just not even heard of anymore. Doesn't exist. They don't even know what it is.
Just quickly, sorry. I just noticed, and I'm sorry, I know I'm interrupting here, but Steve, you said William Ensinger instead of Wilfred. I just wanted to.
I did, yeah. I think Wilfred. We should
probably correct that. Sorry.
Yeah.
I don't know how far back we have to go to.
I don't know why I said William. I was something else in there. But anyways, yeah, it's Wilfred Ensinger. God Almighty, I'd lose a job.
I'm going to dive. I want you, Steve, if you don't mind, to
Yeah,
explain what the different thermal expansion contraction is. You mentioned it very briefly, but not everybody would understand that and understand the importance of it. Could you expand on that just a little bit more for us?
sure. Well, aluminum, everything has a different expansion and contraction rate. Wood, metal, steel, glass, you name it, everything has a different expansion and contraction rate. That's why, like if you see on bridges, you'll see these integrated, look like fingers. Those are
Mhm.
expansion joints. So in the summertime, when it expands, it moves out, and in the wintertime, it cools down, and comes back. Well, the same thing is with aluminum. It has an expansion contraction rate of X. Um, and all the different materials that they've used for thermal breaks in the past all have different expansion and contraction rates. For example, aluminum has X. We're going to say this because I've got the numbers, but it'd be, it's like 2.5 times 10 to the minus fifth power times this type of thing. So we're just going to say the aluminum has an expansion contraction rate of X. Polyamide has the expansion contraction rate of X
Almost
minus
X.
1, okay, where polyurethane has an expansion contraction rate of X minus 10. It moves a lot differently. So basically, what we're saying is that the polyamide basically has almost exactly the same expansion contraction rate of aluminum. So in the thermal cycles, they're going back and forth where it's heating up and cooling down and everything else. Everything is moving pretty much at the same rate. Where if you have something that has a quite different thermal expansion rate, the aluminum is expanding, the other material is expanding differently, and now they're trying to break away from each other. And
Right.
this creates a lot of havoc, and you have breakdown and possible failures in the systems.
Yeah,
I,
and
I,
that's like I think. Sorry,
no, go ahead, Kurt, please.
I was going to say I think that's just an important concept for engineering for any type of product design beyond just fenestration. And obviously, it works in our case here, but that's a sort of a golden rule in many cases to have something with a similar thermal expansion rate.
Yeah, absolutely, and that's kind of why I wanted to make sure we explained it. I think most people will understand it, but just to be sure, Kurt, was there anything more that you wanted to add there?
Sure. Well, obviously it's been more than 40 years since both technologies were initially introduced to the market. So I think it's important to understand that both of them have substantially evolved. But either way, we still fundamentally believe that polyamide provides substantially more benefits to system fabricators. It allows a larger thermal break separation size. One of the other huge things is it allows system fabricators to create systems with dual colors, or what we call split finishes in the industry now. And it also allows system fabricators to adjust their system configurations and glazing depths simply by swapping out the thermal break size. So if you're swapping between double glazing and triple glazing, all you need to do is just change the depth of that thermal break, and it increases the width of your frame. So, but look, realistically, either way, thermal breaking a system is vital, and in many cases, the frame is always chasing that center of glass performance. So I guess you could consider thermal breaking a frame, the equivalent of double glazing your frame, and that's one of the reasons we sort of think that this type of technology became the gold standard in Europe.
Yeah, fantastic. Okay, that was really important for people to understand that as well. Okay, so now, how do these thermal breaks and the use of daylighting within buildings support the big trends? Most people understand that, but I want to hear it from your perspective. How are these thermal breaks um, being able to support the way the world is moving now in terms of building design and
Yeah.
construction?
Yeah. Well, look, population growth, climate change, sustainability, they're three mega trends that I think the fenestration industry is absolutely linked to, or very closely linked to. And we're continually seeing how these have an impact on the way that we do business. Population growth drives demand for new housing, new office buildings, all kinds of new buildings, and these buildings require new windows, new doors. Climate change as another one. And to be honest, even heightened awareness of climate change, they basically drive a demand for a high performing building envelope. That, as I said, can occur through market demands as well as even more stringent government regulations. which means that there's more thermally broken products, better performing products, products moving from not only monolithic glazing to double glazing, but also moving even further from double glazing to triple glazing. And the demand for these high performing building envelopes or products, is also driven by rising energy costs. That's a huge one, right? And better performing buildings and in turn windows means less heating, less cooling. And lastly, sustainability. Not only are consumers sort of starting to demand high performing products, but they also want to know how these products are sourced, what the embodied energy is in this, how much carbon's within the components, what happens to these products at the end of their life. Can they be recycled? Can they be reused? Do they just naturally decompose? And these demand changes have forced some of the way that the technology has evolved. Steve mentioned earlier that thermal breaks are very different to where when they started nearly half a century ago. So.
Yeah, that's fantastic. As you guys know, I work with Solera, which we use honeycomb and aerogel in combination to get like really, really high levels of insulation, R18 or 25. So it's awesome to see progress towards higher insulation levels in the framing systems as well. And then if we can get the overall system R value up, then we can keep people in the sunlight and provide the views that we all know are just so important. Okay, so that leads to my next question. What are some of the innovations, changes within thermal break technologies to push us towards higher overall system R values?
Well, at a real high level, both technologies, both poured and bridged and polyamide, are now offering what's called low lambda material options. And this is all achieved through a foaming process to create porosity within the profiles. This creates air cell pockets within material, which reduces the density and increases its thermal performance. Basically, it's like insulation within the material. So it increases the thermal performance, while in the case of polyamide, the shear values still stays the same. You don't have to worry about any difference in the structural part of it. This is enormously beneficial when the system fabricators, because they are simply able to change out material composition without any design, engineering, manufacturing process changes, and improve their product performance by another factor without having to spend any gigantic amount of money to be able to do this.
Yeah, that
basically supercharges the existing product. So, but yeah, our low lambda product, which Steve just mentioned, we refer to that as the Ally range. So Ally meaning lambda improved, very fancy name. And one of the cool things about that, the Ensinger Ally range actually just got awarded the most innovative system component for 2023 by the Window and Door magazine, which is really great to have that recognition for our new technology in the marketplace with the credentials of something like Window and Door magazine behind it. So, I mentioned earlier, if a normal thermal break would be considered like double glazing your frame, then these higher performing low lambda options could be considered like triple glazing your frame.
Oh, fantastic. Steve, is there any more you want to add there?
Well, some of the things beyond the foaming of the material options, another which is substantially important as the system performance, is reducing a phenomenon called convection. And it all happens within the cavities of the window system. This can occur where even though you've got these really, really large thermal breaks are used and you think you've really got it nailed down, and you would assume you got great performance, but it's impacted by the convective air movement. With polyamide extrusion, some of the early advancements were to move from very simple geometries to multi-chambered hollows, profiles with legs, which we call them flags, or these very simple closed-cell foam inserts that all yield substantial gains in the framing performance by eliminating this convection of cold air movement.
Does that have any impact on the rain screen performance at all, Steve?
I'm sorry?
Does that have any impact on rain screen, on water drainage?
If it's designed properly, it doesn't bother. It won't do anything with water drainage. And one of the other things too is by able to stop this convection, you also have the ability to reduce the amount of possible condensation that you could get with inside these cavities, and requiring to have all that drainage brought out. But by eliminating the convection, you increase the U values of the system dramatically. You reduce any possibility of condensation getting in there, and you reduce the condensation resistance factor. These are all things that you all try to strive against, but a lot of it is overlooked because, again, I've got a big thermal break in there, and it should be doing exactly what it's supposed to do, which it is, but you're killing it by having this big, large hollow, and you try to break it up a little bit.
Oh, that's fantastic. That's brilliant. Actually, I hope you guys are talking to Adrian Lowenstein. You guys got to get yourself on his program as well. I'll introduce you. What's that?
Yeah, if you can introduce us, that's one of the things we really want to do.
Oh, I will for sure. Yeah, you guys definitely want to chat with him. All right, so back to the improvements, right? So how are these improvements how does that translate to maintaining that connection to the natural world for the building occupants through view and through daylight?
Yeah, well, I'll jump in here, but windows and doors are critical to occupant comfort and happiness. Passive heating, ventilation for fresh, healthy air, and I mean that's really what daylighting is all about, right? As regulations have tightened and market demands for more efficient products sort of changed some of the dynamics. This still allows us to maintain a good window-to-wall ratio in buildings. Essentially, a better performing window means that it has a less impact on the overall building performance. So, it gives designers a little bit more freedom to achieve these and equally other important objectives in that design. I mean, no one wants to live or work in a building that has little portholes for windows. You feel like you're on a ship or something like that. That restrict daylight, fresh air, just because they had to reduce the window size to meet some arbitrary building performance requirement. So another design megatrend that we're seeing, particularly in that high-end residential segment, is that people, not only do they want larger windows with better views, but they also want to see less of the window. They want narrow sightlines. They want these grand entryways, indoor-outdoor spaces that can be opened up with multi-slide or stacking products that cover 20-plus foot spans. So, having larger windows and doors really do benefit the occupant, particularly when correctly positioned and correctly specified, because they allow more passive heating, more fresh air, more ventilation.
Oh, you are absolutely speaking my language. That's wonderful. All right, let's talk about the government. Codes and policy and guidelines. What kind of impact is that having on the industry, on your industry?
Well, Ensinger collaborates with the customers, providing application design support during their development phase. And I can tell you certainly, by saying the introduction of Energy Star version 7, it kept me busy over the last couple of years. This has really been something because they keep lowering the U values and have to have a higher performance system. We have several key customers who have been revamping and redesigning with new innovative systems and push the boundaries, thermal performance while maintaining narrow sight lines. However, having said all that, I would say both consumer demand and regulatory codes have fairly strong pull on industry performance. Everybody, like Kurt mentioned, everybody wants these big, massive sections of glass, but they don't want to have any framing system. Well, you need the framing system to hold in there, and it has to be thermalized to be able to work properly with the glass. So with Energy Star, we saw many residential systems being redesigned to suit the more stringent requirements, which was absolutely a positive thing for our industry. Made the systems designers and specific performance targets, gave us a lot of flexibility in those changes to look at what we're going to have the biggest impact. It also allowed us to redesign around more common standard profiles, which in some cases had a positive impact on the cost structure of the customer. We also saw customers moving from different thermal break technologies and using regulatory changes as a catalyst to modernize their product. Changes to use something like Insulbar in a range and give you much better U values. Not only Energy Star, which is a residential-based code, there have been similar advancements in commercial codes, and requirements. And we're also seeing certain municipalities impose their own stringent, what they call stretch codes. And it's a stretch, believe me. Energy Star is now going to be mandatory in future in Colorado. All residential has to meet Energy Star approval. It's not just IECC or ASTM or NFRC or any of these others. Now every system has to meet the Energy Star mandates. Title 24 in California as well. Now they get into the commercial city codes, New York City, Boston. They've all got their own versions of these stretch codes, which are making it way more stringent and much more difficult for a lot of companies to compete to get the U values what they need to be. On the other hand, there's also that little schoolyard competition that everybody likes to have. At some point a little while ago, a few years ago, I should say, we had a customer that completely redesigned their systems. It just went soup to nuts and wanted to have the best performance system they could. We're going to give them a crazy name. Let's call them Acme. I feel like Wile E. Coyote, but okay. We'll give them Acme Windows. They redesigned all their products, and they get a huge jump on everybody else. So their performance was so much better. And we were instrumental in it and helping them get that way. They wanted to be the best performing locally produced product. We then referred to this as the Acme effect in the market. It was kind of funny. As we had other customers coming to us and say, hey, Acme did this. How can we do this? How can we get similar results? So how can we get there? So this was important because now we have consumers looking for performance figures, and we'll also make some decisions based on that. It's like going car shopping. And obviously the impact of fuel economy is going to be way heavy on your decision. The better performance, the more impact it has on your decision to purchase, especially with the price of gas these days.
Yeah, oh, amen. I'm going to have the Acme guys on the show sometime. Since we're virtual, hopefully they won't be able to drop an anvil on my head while we're online. So
there was something like an NDA involved there. You have to just be
a no anvil waiver or some such thing.
Yeah,
it is
no anvil clause in the
no
contract.
anvil clause. Yeah. Absolutely. It is really great to see the industry moving in this direction, and for so many reasons.
Yeah. And like, that's not just the US, right? Like, if we look around the world, we see these type of regulatory standards improving. And I touched on this earlier, but the US is still behind where the rest of the world likes to see some of these performance requirements. You compare what our standards are to, say, Germany, for example, and even our best performing products may not comply. I think and don't fact check me on this, but I remember reading something, I think it was in Scotland, that they just recently introduced that they're making all residential stuff require passive house certification, I think, which is a huge change for, at least the fenestration industry. So, which is really, really interesting. And, it's going to just continue down that path, even here in the US. So, but, we touched on this earlier, that it's really important just to understand sustainability isn't just about performance. It's also about the material choices, end of life recycling. Are you shipping your products all the way across the world, which increases embodied energy? And one of the fantastic things about aluminum windows, or even aluminum as a material, is it's infinitely recyclable, and a huge portion of that embodied energy remains consumed upon its first production. So recycling and reproduction requires much less energy to produce or to refabricate it into something else, and that really contributes to the sustainability of the product. So again, one of the things I think is more popular in Europe is the choice of low carbon or post-consumer recycled aluminum options. They're available, they're gaining popularity, and one of the great things about polyamide, like aluminum, is it is almost infinitely recyclable, assuming that it's kept clean in that recycling process. Ensinger actually offers a fully recycled certified product in Europe, and we're seeing some demand growth in that product over in that market. Here in the US, we actually offer a take-back program where we take back unused or obsolete profiles, and then we recycle and reuse them. And by recycling these obsolete and unused profiles, this not only helps reduce the amount of landfill, but it also positively impacts how much plastic waste ends up in oceans and other natural environments. Like aluminum, the recycling process also requires significantly less energy than producing new material. So it has a really positive net benefit on greenhouse gas emissions. In the US, demands for a recycled or certified recycled product aren't quite here yet, but it's something on our radar. It's something we have the supply chain capability to do locally if the market pushes for that. And one of the other sustainability elements that we see critical is with our product, we deliver it on a returnable stillage wherever possible, at least anyway. And by using these reusable steel cradles, we actually eliminate single-use packaging. That again, mostly end up in landfill. We also reduce the labour for the customer or fabricators that don't have to break down those crates or packaging and throw them away to do it safely. And this is actually an initiative that Insulbar has in place globally, and I think it works really, really well. We're like 15 cycles now on these steel cribs, which is at least 15 crates each time that don't end up somewhere in landfill.
Yeah, that's brilliant. And Kurt, we didn't even talk about lifespan. Like aluminum has a long, long lifespan, and the polyamide is not exposed to the sun, so it's going to have an extremely long lifespan as well. I had a guest on recently that she made the statement that the greenest building is the one that's already built. And so if you build a building that's lasting for a long, long time, you are contributing to sustainability in a big way. So, I have to thank you guys very much for joining us on the show. Before we go, if you could summarize today's topics and important thermal breaks and how important thermal breaks are to daylighting objectives just before we sign off, please, I'd love to hear that.
Thanks, Joe. It's been a pleasure joining you today. I think the most important thing for me is that what it boils down to is a higher performance product, which uses high performance thermal breaks, allowing consumers to manage their window and wall ratios. This is critical to occupant health and comfort. The market is continually evolving, and the systems need to keep up with regulatory codes as well as consumer requirements. I'm pleased to see the way our industry is moving, and I can't wait to see what it looks like in 10 years. Well, maybe you can have us back for part 2 follow-up. Who knows?
I would love that.
Steve's going to be with us for another 10 years as well.
No, Steve will not be with you, but that's okay.
Well, I sincerely hope I'm doing this in 10 years because I enjoy it immensely. And I have to say the worst thing that could happen to us is if we end up going back to those sort of 70s Soviet style buildings with the occasional little punch out here and there. And the work that you guys are doing is going to drive the overall system our value for the window systems. And I can't thank you enough for that work. And I can't thank you enough for being here today. Thank you very much, guys, and take care.
Thanks, Joe.
Thank you.